Everyone, and welcome to Global Platform 17th edition of Tech Talk. In today's session, we'll be exploring the economic value of open source. This topic is increasingly relevant as open source software continues to shape innovation, collaboration, and competition across industries. And it is my pleasure to welcome our speaker for today, um, Frank Nagel. I hope I pronounced the name right. Frank is
Yep.
a research scientist at the Initiative on Digital Economy at the Massachusetts Institute of University and also serves as the advising chief economist at the Linux Foundation. His research focuses on how competitors collaborate to develop shared technologies while still competing in the products and services built on them, a dynamic central to open collaboration and innovation. Frank's works is particularly centered on artificial intelligence, open source software, and cybersecurity. It offers deep insights into how these areas drive both economic and technological progress. And without further ado, Frank, I'll give you the floor for your presentation in today's Tech Talk session.
Great. Thanks so much. It's great to be here with everybody. Thanks for having me. I'm excited to talk with you all today. So as mentioned, a lot of my work focuses on open source software, and so that'll be sort of the grounding of a lot of the research that I talk about today. But I think there's a lot we can learn and apply to open source hardware, and I'm curious to learn from all of you. Happy to have a discussion in the back half of this and hear more about any thoughts you may have on applying this to open source hardware, because I think there's a lot of similarities certainly between open source software and hardware, but the obvious difference is we're dealing in the digital world versus the physical world. But I think that there's many things we can learn there, and also many of the challenges that we faced in measuring open source software are actually even in many ways more complex in measuring kind of the value of open source hardware. But I'll talk more about kind of the hardware aspect at the end. So today, I'll be kind of focused on some of the research that I've done and a few others have done thinking about this, how do we measure the economic value of open source? And I'll start, sort of at the very broad level and kind of like the economy-wide level, and then we'll drill into kind of the company level and thinking about how we can, measure value that's created by open source within companies. And so, I'll just as a sort of a background, today in my current role as a research scientist at MIT and chief economist of the Linux Foundation, I think a whole lot about equations and algorithms and things like that. But I was also in the cybersecurity space for about a decade before returning to the academic arena, and so thought about equations and algorithms in that area as well. So and just to kind of get us started today, I'll put up an equation that is a fairly basic one we use in economics a whole lot, to think about how we measure value created by something, right? By anything, a product, a service, what have you. And so usually we just think about the price of the product times the quantity that's sold, right? This is very kind of Econ 101 way of thinking about things. And so years ago, when we decided we wanted to try and measure the value that open source was creating, we said, okay, we have these basic equations from economics. Let's try that. Now, of course, the obvious problem with applying this to open source is first that, for most of open source, especially in software, the price is going to equal zero or basically zero, right? And so price is not really revealing a whole lot of information in terms of the value that any one good is creating. So then we can think about quantity, and here it's even more complicated because when we have no idea how much of this stuff is out there, because it's open. It's once you download it from somewhere, you can easily copy it and make it available within your environment. And so it's very hard to measure this stuff because there's no sort of central place to keep tabs on the usage side. I'll talk more about kind of the supply side versus the usage side, and I think we see a lot of the same issues from this measurement perspective within open source hardware as well. So, economics doesn't, at least at the face value, doesn't have a whole lot to say about the value of open source, because p is 0 and quantity is basically impossible to measure or very difficult to measure. And so we can think about, leave economics behind and think more about the business world, and think about something Warren Buffett has said many times: price is what you pay, but value is what you actually get. Right. And so we can think about, yes, the price may be 0, and but that doesn't mean that the value is 0. And so I'll walk you through today. Some of you may have seen this headline number already, but we've done a bunch of sort of ways of thinking about this and ways of calculating this. And we've come up with this number of $8.8 trillion as the value of open source software. And this is definitely, we argue this is actually a bit of an underestimate, but it at least gives us a starting point that we can have a conversation about, the value that this is creating. So with that as kind of, the starting point, I've worn all these different hats, but in a different world, I would have been a physicist, an astrophysicist. This has always fascinated me. In particular, this notion of dark matter, right? And I think this is something that actually very much applies to the context that we're talking about today, and to open source. Because with dark matter, it's something that we know is there. We can see its impacts on other things. But we can't measure it directly, right? Or it's very hard to measure it directly. And so over a decade ago, when we, were thinking about how do we measure this stuff, we didn't have, kind of a lot of the great data and tools that we have today. And so we decided to start kind of small and thinking about this kind of digital dark matter in the context of one open source project, and that was the Apache web server, right? So, this is 10 years ago, but this is where this all started. And so Apache was a good place to start because it was very popular and widely used, but even more importantly, that the whole point of a web server is to serve stuff on the web, right? And so we can actually go out and measure this using some of the the old hacker tools that I had to kind of scan the internet in a legal way, of course, to basically try and understand what the Q was here, right? What the quantity of Apache was. Now, of course, this is again going to be sort of an underestimate because people can use web servers internally and all things like that. But at the very least, this would give us some number that we could wrap our heads around in terms of how much Apache is out there, right? And so we do these scans of the U.S. internet space, and measure and come up with a number of how much Apache web server is actually out there in the U.S. And then to solve the price problem, what we do is some stuff that Bill Nordhaus, who won the Nobel Prize in economics for other things, but has suggested for a long time, to kind of, if we're trying to measure stuff that doesn't have a price, or the price doesn't fully reflect a value, we use what's called a replacement cost, right? So we think about something that is sort of similar and roughly close to performing the same function that the thing we're trying to measure performs, and we use the price of that, right? And so what we end up using is the price of Microsoft's IIS web server, right? So now, of course, Apache and IIS, there's lots of differences in many different ways, but at the very least, this is something that's performing a lot of the same functions in that it's serving web pages, right? And that it's designed to that's what it does, right? And so there's again, this is sort of back of the envelope, but allows us to come up with, now we have a Q, now we have a P, and so we can actually estimate the value of Apache. This is again back in 2013, 2014, at about $12 billion, right? So if Apache didn't exist and everybody who used Apache, it's from the count that we got, had to replace and use Microsoft's IIS on a Windows box, that replacement cost would be about $12 billion, right? Now, that sounds big, but we don't have a lot of benchmark or kind of framing for that number. And so what we did is we compared this to kind of what else was going on in the U.S. economy at the time, and we show that this number is about 9% of what all companies in the U.S. were spending on prepackaged software, right? So and so that's gives us some benchmark to be able to say that this is a pretty big number, especially when we consider that this is just one piece of open source, right? This doesn't include Linux or browsers or what's become the cloud and everything like that. And so this is, I think, started a conversation, because because this allowed us to really help understand, how does this compare to the value of, the broader software industry, right? And we also thought about another way of estimating this value more on the kind of the supply side. And so the Apache web server, if you don't know, the history of it, it came out of one of the federally funded national supercomputing centers. And so we couldn't find like great numbers on exactly, the investment that went into Apache specifically. So instead, what we did is we looked at if Apache was the only thing that came out of the national supercomputing centers, this still would have been a 19% return on investment by thinking about this value that Apache created. And so, obviously many other things have come out of the national supercomputing centers, including a whole bunch of hardware designs and technology. But again, thinking about the return on investment here, it's actually quite large, right? Like for our MBAs, we often tell them if you're getting like a 5 to 6% ROI, that's pretty good. If you're getting 10%, that's excellent. And so something like a 19% ROI is amazing, right? Like that's definitely something we want to think about investing in, because it's going to have this massive return, right? And so, so I think that this was a kind of work that we did again, this is 10 or 15 years ago, and it's very focused on one piece of software, right? And so, so years later, what we did is we wanted to better understand the broader open source ecosystem. And so in working with the Linux Foundation, we partnered with a number of software composition analysis companies. And so what these companies do is they go into their customers and they scan their software, their code bases. Mostly it's for kind of to make sure they're not violating open source licenses or any other types of licenses or anything like that. However, as a byproduct of that, they then, we only, for the first census or the second census here, we only worked with 3 companies, and we managed to get data on thousands of companies, and over 600,000 data points of open source usage. And so now we've, at least partially solved for Q. And then, but this was a few years ago now, and then just 2 years ago, back in late 2024, what we ended up doing was doing another version of this, but the companies had grown in that time, and we added a 4th SCA company. And so now in this later version, we have data on over 10,000 companies and the open source that they use, including kind of 12 million data points of seeing individual pieces of open source being used within these companies, right? So now we have pretty good handle on Q. I will say, of course, that this is at the application library level. So this is the open source that's sort of being baked into products that they're making. So this is missing anything that's sort of more on the infrastructure side of things. So the Linux kernel, just as an example, is actually not in this count, and things like the cloud infrastructure are not in this count. But we're actually in the process of ramping up the next version of the census, where we're going to still look at that application library layer, but also dig deeper into the infrastructure layer, especially the cloud. And so stay tuned for that. Hopefully in early 2026, we'll have an update to this, and we'll have these numbers will be much larger, because we'll be looking at what's happening in the cloud and the infrastructure layer, not just the application library layer. So stay tuned for that. So we have our Q, which is good. So now we can think about the value that this is creating, but we still need a P. It's hard, and at this sort of scale, with this many different types of open source packages, it's going to be harder to do that sort of replacement value trick, because we'd have to find a replacement value for every single one of these packages that are in here. We ended up narrowing down to kind of the most commonly, I think, that the top 2,000 or 3,000 packages that we see in this data set. But even that is going to be hard to come up with some replacement value there. So we use something slightly different that I had used in a different context before, to measure kind of the impact of a French regulation back in 2012, where they changed their procurement preferences such that they have a preference for open source software when you're submitting an RFP for the, or a proposal for a government contract, right? And so, I won't go into the details of that study. It creates a whole bunch of value for the world and for France. But what's important to what we're talking about today is that we use this method called the Kokomo 2 model, which is essentially a way, it was actually developed by the DoD in the United States as a way to kind of estimate the prices they should be paying for large software projects. So what it does is it takes the lines of code that are in a project and helps convert that into a measure of person hours so that we can actually think about, okay, if a piece of software has X lines of code, it's going to take about, it's going to take 100 people 2,000 hours or whatever the calculation comes out to be in terms of person hours. And then we can sort of back that out into the value or the cost that it would take to create that by using a labor cost estimate. So the average value of a software developer, and we multiply that times these person hours, and we get some understanding of the value that's the open source is creating, right? And so in the case of this this French regulation, it was about $20 million of value creation. Now I'll save you the time of yelling at me in the comments and saying that lines of code is not a great way to measure a piece of software, especially today in the context of Gen AI, which I fully agree with. But again, this allowed us to get at least some sort of reasonable number that we can start having a conversation with. And there's been a few other studies that have used this method as well. And so there's two other studies in particular I'll mention. That one was looking at the value of open source created by European Union companies back in 2018, and they estimate this kind of value of creation at about $1 billion. 1 billion euro. And then another one looked at the value of open source created in the US in 2019, and it was about $38 billion, right? So now, all of these studies, of course, the problem is that for them, essentially Q equals 1, right? So for all these studies here, they're just looking at sort of if open source disappeared and we had to rewrite all the open source that's out there, then that would be the cost, right? Or at least the open source coming from the EU or the US or France in the study I did. And so so here we have this other method of getting at P. But all these studies, again, Q here equals 1. Now, of course, we have the census that I just mentioned, so we have a measure of Q that's not just 1, and now we have this way of estimating at least the labor cost for each open source package. So we have Q, we have P, and we can now start to do some math that kind of putting a value on the whole thing, right? So if we sort of look at this from the open source disappears and we have to recode what we were focused on here again was like the 2,000 most widely used open source packages. That replacement would cost about $4 billion, right? And again, this is that's Q equals 1. But when we think about a slightly different thought experiment where open source doesn't exist at all, so it's not just that it disappears and we have to recode it. Instead, if open source didn't exist at all and all the companies that use open source had to either code it themselves, or we live in a market economy, what would be more likely to happen is that some company would come in and write all that code and then sell it. So that would add or that would lead to about $8.8 trillion of value that's being created, that's essentially that's showing up as a zero in GDP or any other way of measuring economic activity today, right? And so so that $8.8 trillion obviously is a very large number, and that's essentially what would happen if open source didn't exist at all. Again, we're only focused on the 2,000 most widely used open source packages in this context. But to kind of again give some context to that number, what that means is that every company would spend about 3.5 times more on software than what they spend today, right? So that's open source is creating this huge value for companies, and if it didn't exist at all, and they either had to write it themselves or pay somebody else to write it for them or to buy it, then they'd be spending about 3.5 times more on software than they spend today. And another thing to think about here And I think some of you have probably seen some statistics like this before, but there's sort of this long tail of the value that's being created here, such that about 5% of the contributors to these, again, top 2,000 packages are creating about 96% of the value, right? And so it's certainly very interesting to think about how how we're capturing this, or who's creating it, and how we may need to support it. And we'll talk more about that in a moment as we think about kind of the supply side and the creation of all this stuff. And then lastly, of course, as I've already alluded to, this is still an underestimate of the true value, because we're only measuring the popular application level libraries here, not a lot of the infrastructure. And again, we'll be working on that in the near future. So we have this kind of value creation metric of quantity times price, but so we kind of had our economist hat on for the moment. Let's shift and put our MBA or our business hats on, and what we care about there is going to involve this sort of cost, right? And so when we think about value captured for a company, we think about the quantity that they're producing, and then but instead of just multiplying by price, we do price minus cost, right? So sort of the value that they're capturing for an individual company. And in the context of open source software, what is the cost? It's all of you that are on this call, right? It's people contributing to open source on behalf of their companies, right? And so a lot of the more recent research that I've done has been digging into all these types of things at the company level and thinking about why are companies using this stuff? Why should they contribute back? And what we find is that at this point, as recent as 2024, 97% of companies are using open source. So open source has sort of won the day on the usage side, but on the contribution side, we don't see quite as many companies giving back, right? And this is despite some evidence, from myself and from others, showing that open source contributors can gain 2 times the productivity boost of using open source compared to free riders who are not contributing. And in that French study, I actually show that at the country level, we can contributing to open source leads to increases in IT employment and increases in IT startups, and all these types of good things at the country level as well at the company level. Now, I will say that, in these contexts, it's not always the case that everybody should be contributing to open source all the time. So I'll talk about in just a minute sort of a framework that I developed to help think about when should you contribute and when should you not. And actually, I'll also point out that the Linux Foundation, we're in the process of developing a return on investment type of calculator to help companies do this more in their own environments and think about what are the values to contributing back to open source projects in their own environment, right? Like these studies that I do are more broad, and I think every single company is a little bit unique and is different. And so our hope is to release something probably in the next month or two that allows all of you to think about your own enterprise, your own company, and the software that you use within your own environment, and whether that makes sense to where you should contribute or more or less, or things like that. So I mentioned startups here, so we can also think about some research of mine and again others that have focused on startups. And what we see here is also quite interesting, that at the startup level, as we increase contributions, startups that are contributing more to open source often have larger venture capital investments, higher valuations, and they're more likely to have a successful exit, right? So either an IPO or an acquisition or something like that we would consider a good exit, right? They're not going bankrupt or things like that. And then at the sort of country level, again, with thinking about our manager hat versus our economist hat, we can see at the country level that investments in open source lead to more tech startups. They lead to higher quality tech startups, and they lead to tech startups that are more globally oriented, right? So these are ones that are going to be more likely to be higher growth because they have a more kind of global orientation and not just focused on their home market. So that's kind of these, again, we can think about the value from using open source and contributing to it at the kind of the company level and at the big company level. We can also think about it at startup level. But again, as I said, it doesn't always make sense for companies to contribute to every single project that they use. And so, last year I sort of wrote up this thing that essentially is trying to help companies think about when should they be more collaborative and contribute, and when should they be more competitive, and be more, be less collaborative, right? And so the way that this ends up playing out, and I'll spare you kind of the details from the back end, just in the interest of time. But there's sort of 5 characteristics we can think about when it makes sense for companies to be more collaborative and contribute more. The first is if a technology, whatever it is you're working on, is very early or very late in the tech life cycle. Then we're going to see companies collaborating and contributing more, versus sort of in the middle of the tech life cycle, where we expect them to be more competitive. We're also going to expect that things that are lower in the tech stack are going to be more collaborative, and further away from kind of the end consumer. And obviously, in the context of hardware, we're pretty low in the tech stack, and so I think I'm sort of preaching to the choir here in this group that that we would expect to see more collaboration happening at these kind of lower levels of the tech stack. Third, then thinking about what the market for this technology itself, whatever the technology is. If the market's less likely to be a winner-take-all market, where we're going to have one, maybe 2 companies kind of dominating a space, then we're going to see more collaboration. And the one kind of caveat to that is that if there is likely to be some sort of winner-take-all market, and you can potentially control a standard within that market, then it actually makes sense for you to be more open and more collaborative, because you want everybody on your standard. This is, say what you will about Elon Musk and Tesla and the vote that happened yesterday to make him the world's first trillionaire, potentially. Tesla under Musk years ago opened up a whole lot of the patents that they had around battery technology in an attempt to sort of shift the electric vehicle market towards a standard that they controlled, right? And so now, 10 years later, after they did that, we see most companies have sort of shifted to the standards in battery charging technology, EV technology, that Tesla essentially controls in many ways. Granted, they made it open so everybody or more people can use it, but they still have sort of control the reins around that, right? So that this more openness actually ended up being a very good thing for them. Then fourth, when we think about the levels of competition in a particular market, at very low levels of competition, so we're thinking there's not many competitors, or it's there's not a lot of competition happening, or in markets where there's very high levels of competition, so there's tons of companies making the exact same thing, almost sort of a commodity market at that point. We would expect in those 2 areas we'd see more collaboration and less in sort of the medium levels of competition. And then finally, thinking about the level of sort of social acceptance of the technology, and as part of that, thinking about the level of regulatory clarity. When there's low social acceptance, so the technology is new and people don't understand it yet, or haven't accepted it yet. We can think about the self-driving car markets, today or even a few years ago, or in a market like the AI space today, where there's not a whole lot of regulatory clarity. We would expect that we'll see more kind of collaboration between companies across the board. And so this all sort of sums up into this argument that we want to collaborate on the core and compete on the edges, right? And that's, I think, where a lot of companies today are trying to think about, what is the core of the technology that in their industry that they work on, and how can they collaborate on that, versus where is the competition happening on the edges that are closer to the end user and to the consumer, where there's more differentiation and more room for kind of separation between companies. And that's where we're going to see less competitive behavior. And so that's a lot of, that's kind of a quick summary of a lot of the work that we've done in this space, and myself, others, my team. And here's sort of, where we're headed, right? So obviously AI and ML, we're actually in the process analysis of, this paper is public, but looking at the impact of AI on open source developers. So when open source developers got access to GitHub Copilot, we see this big change in the way that they work. It increases their coding activities and decreases their project management. And this isn't public yet, but we're digging into some of this and looking at how the effects can be bigger for not only less experienced people, but also for women. And so thinking about the tensions here, or the nuances to this headline effect of this sort of rebalancing of the way that people work. And we also see people exploring more and working on new projects more, or new languages in the software space. And then we also see people working less collaboratively and in smaller and smaller teams, to the point where sometimes the team size is one. And that's, I don't know if that's a good thing or a bad thing, but people are enabled to do more work by themselves. But as a result, we may be losing some of the nice collaborative innovation that we get through talking to each other and working together. So that's something that we're digging into as well. And then hopefully in the next week or two, we're actually going to be releasing some work that sort of estimates the value of open source or open model AI, and looking at kind of how open models are contributing to the AI economy and in comparison with closed models. And so we've been doing a bunch of work on that as well. So what's also next is, as I already mentioned, we're looking at expanding the census and the value of open source into the cloud, and going deeper on the kind of broader on the tech stack in terms of the understanding the value that open source creates. And then, most relevant to this group, we're also starting to dig into, open source hardware, right? Which I think is, I'm guilty of this myself, but is often overlooked by, folks from the academic area trying to study this stuff, mostly because the data is just harder to get at, right? And so, but even still, I think there's some things that we can learn from, from this research about open hardware. In particular, this notion of collaboration at scale and this sort of modular innovation, which again, I think I'm, preaching to the, believers in this space. But thinking about not only, coordination, like there is for Git, for versioning control within the open source software community, but also thinking about kind of standardized libraries and tools and things like that, that can allow for more collaborative behavior in the hardware space as well. Right? And second is thinking about transparency and the trust and security that comes from this. So I know this is something that this group cares about, is thinking about how transparency in the build process and in what's going into the chips and sensors and devices can be very critical for supply chain integrity, right? And so this is something we're seeing more, again, on the software side, the SBOM, the software bill of materials, and understanding what's being baked into the software you're buying. I think we're going to start to see more of that in the hardware space as well. And then lastly, thinking about shared infrastructure and how can we lower entry barriers and use open source hardware as a way to think about sharing fabrication, intellectual property, and thinking about open manufacturing tool chains and some of the tools again that we already have, but how can we go further in allowing for this shared infrastructure, and again this sort of notion of collaborating on the core and competing on the edges. And then finally, thinking about the value of open source hardware, I think how, it's the same problem we wrestle with in software, right? Like, how do we measure Q and P? He may be a tad easier here, actually, because there's plenty of replacement cost possibilities and thinking about the non-open versions and various things like that. But I think Q will still kind of create a problem. Although here, where the openness is being baked into a physical product, perhaps it might end up being easier depending on how distributed the production processes are to measure Q. But that's something we're thinking about at the moment as well. And so lastly, these kind of key insights, open source shows that value scales with shared standards and reuse. And open source hardware is moving in this direction and can unlock, these similar spillovers as more of these kinds of costs start to fall as a result of, this more supportive and open environment when we're thinking about collaborating on what the core aspects of the technology while competing on the edges and what's built on top of that. So just to summarize, again, the kind of headlines here that open source adds about $9 trillion of value to the economy. Companies that are contributing to open source software can get up to 2 times the amount out of using it as their kind of free riding peers. And then, this notion of collaborating on the core and competing on the edges helps us understand when we should be more collaborative and when we should be less collaborative. And then finally, as I just referred to, we can apply some of these lessons that we've dug in, we've learned from open source software to better understand the value of open source hardware and to think about how we can, when companies should be more collaborative or less collaborative as well. So that's it. Happy to open up for questions and hear what all of you think. So thanks so much, and please feel free to reach out if we run out of time for questions or if you have anything you want to chat about. Thanks.
Any questions from anyone in the group?
Yeah, thank you. Hi.
Yes.
Please. Hi.
This is Jan. Hi. Thanks for the presentation and also your work on this in general. It's already been very helpful to argue for
Great.
open source also in corporate context. So first
Excellent.
of all,
That's my goal is to give everybody ammunition to argue with their bosses about.
That's definitely working. That's
Great.
working so far. So first of all, I had a hint regarding open hardware. Maybe you're aware of it already. And there's an interesting case study about component sharing in the 3D printing space. I saw that personally when trying it, where like standardized screw sizes like M3, M4, M5, etc. There are parts that you can get from different sources, and that helps you a lot in 3D printing.
And that's a great point.
Analogy for
yes.
for other hardware.
Nope, I think that's a great point, because I think the 3D printing community, right, has a whole bunch of open activity in it, right? People sharing designs, people trying to standardize, to your point, right? And so there have been, not that academic studies are like the be all end all, but there have been a few academic studies digging into the 3D printing communities to better understand, like how does that affect the companies that are working in them and like the way that they're, thinking about that. I think to me that, that's sort of like the tip of the iceberg of open source hardware, right, in general, because we're thinking about, yes, it's definitely a transfer into the physical world, but there's a far cry between, 3D printing plans for things that like you're making at home or like things like that versus, what, kind of the chip side of things, right? So that said, like I think there's a lot, again, we can, we can learn from the software side of things, but there's a lot we can learn from the 3D printing side of things as well, in terms of like, again, like how does this impact like the competition and the profitability of companies in those particular spaces, and what can we, what's the same, what's the difference, different when we move into the silicon space, right, and start thinking about that area. That's a great point, though. Thank you. Yeah.
Second part, sorry. Yeah, was the question actually is you already aggregated this value very well for the overall economy, so you're probably guessing already where this goes. Like, do you have any recommendations or stuff to share how to break it down again to an individual company? Like, what is the value of open source to one particular company?
Totally. So that's what we're working on like right now, right? Like with both my MIT and my Linux hats on, we're trying to build this return on investment calculator to show, right? So I mean, look at it this way, right? Like you as a company, right, could kind of do an audit of what's all the open source that's in your, in the products you build in your company, and et cetera, et cetera. And then you could do that, those Kokomo analyses are pretty straightforward, right? Again, like lines of code. It's not by no means a perfect way of measuring it, but at a pure, I've talked to companies that have used that as a way to kind of show to their leadership, like, look, if we had to write this stuff by hand, here's how much it would cost us, and here's here's all the packages we rely on, here's how big they are, number of lines of code, and here's how much that would cost us, right? So that's sort of like a baseline way that I've heard some companies trying to, again, argue that like using open source is good. And then there's sort of the, the arguments that we're trying to formalize and bake into this kind of calculator of like when and why should we give back, right? So one of the examples I've heard from a few companies is that like, there's like, we can do like a sort of Kokomo value type of thing. But there's some open source packages that like we need to make small tweaks so that they work in our environment, right? And we need to, give that back and contribute it to the open source community. But if we're writing 5 lines of code so that 10,000 lines of code work in our environment, and we don't have to write the 10,000 lines of code, we just have to write the 5 lines of code. That's going to be another way to think about the return on investment of contributing, right? And I think too, these kind of arguments of like the collaborate on the core and compete on the edges, thinking about, my favorite example is I was talking to a large car company, and they were pointing out the little toggle switch that moves your seat back and forth, right? Nobody's buying one brand versus a different brand because of that toggle switch. But if it didn't exist, you might not buy the car, right? Like if, I'm old enough to remember you had to use like a lever, and like, it was very clunky and it wasn't as smooth and all these types of things. And so they use that as an example of something that like it's adding value to the car, but the fact that the toggle switch exists and like we need a toggle switch in the car, but we don't have to build that software by ourselves, right? Because that's not the reason that somebody's buying, whatever car instead of a competitor. And so I think that those two types of examples of like, the example of like we can write 5 lines of code and then get 10,000 lines of code for free is, that's a reasonable, like powerful argument that I've heard companies use. And then this other one of, this thing, we need it, but it's not really the reason that our customers are buying whatever it is we're selling, right? And so, that's a more of this collaborate on the core, like, we need that thing, but it's not why the customers are buying our car instead of somebody else's. So we don't need to do it ourselves, right? And again, if we need to contribute a few lines of code to help write that, then we're saving all this effort too. And so that's the type of stuff that we're trying to formalize in these calculators that we're working on. That again, I'm hopeful they'll come out by the end of the year, maybe early next year, so that it's much easier for for everybody here to plop in the projects that you rely on, and then think about the contributions that you're making, and better understand the kind of ROI for the return on investment for your specific company.
Okay, looking forward to it.
Great. Yeah, stay tuned.
Hey Frank. So
Hey, Tom.
thanks so much for doing this. Really, really appreciate it. This is a great I think articulation of the value of open source. I was just curious, have you or has anyone else done work on sort of specialization to a domain? I'm thinking particularly like in security and cryptography. It's the internet is basically all uses open source cryptography, right? Like whether it's
Yeah.
OpenSSL or
Yes.
Boring SSL, and that's one of those places where it feels like the value is even like probably greater because it's like very, very specialized and like. But so has there been any looking at like per domain kind of thing of like what the value is specifically there, if there's like a multiplicative factor or something like that, which was you kind of expect that.
So yeah, no, so that's a great question, right? And I think we all learned the value of OpenSSL back when Heartbleed happened, right? And that in particular was, and there's actually some like industry estimates of like how much people had to spend to fix this thing when it rolled out, right? Like, and so there, again, that's a very specific example though, right? But to your point, I think that's it's a good question. We haven't like sort of sliced and diced stuff by like function, right? Like or by like the role that the things play, whether it's cryptography or network architect, like layer types of stuff or things like that. We can certainly look at that a bit, but I think at the moment, like we're just trying to get like a measure of like the quantity that's out there, right? Like that's kind of where we figured was the starting point. And now we're at a point where we can start digging in a bit deeper, and we haven't done that yet, but I think there's certainly a case for that. And I would argue too that I think in thinking about like something like OpenSSL or like security, like cryptography, that's going to be, at least to me, like more at the core layer, right? Like at that kind of core, like it's not necessarily why somebody's buying one thing versus another thing, but it's something that's super important for everybody to have, right? So to me, that's like definitely a good example of something that should be more collaborative and open, because that's like just so fundamental to doing everything, right? Like again, like the chair switch, right? Like the toggle switch for the chair is like a super important piece of the car, but it's not necessarily why people are buying things. Now, that's not true of everybody, of course. Like you have some industries that would be super, want to invest more heavily in security and everything like that, which makes sense. But and this is coming from somebody with a cybersecurity background, for better or worse, like many companies are less worried about cybersecurity than perhaps we might like. And so, I think, and therefore it's less of a differentiating factor why they buy, one thing versus the other, right? But yeah, I think some specific like sort of, or not even verticals, right? But like technology classes are worth digging into deeper to kind of think about, the broader set of value that they're creating. And my hope is that some of this stuff that we're trying to do in the cloud context of measuring the use of open source is going to shine light at least on some pieces of that. Not everything, certainly, but helping to understand better at like the lower infrastructure layer, what are the types of things that are really everybody's relying on, right? And I think in the context of OpenSSL, if you had asked people, 5-10 years ago, whenever Heartbleed was like what are the most important open packages, like people may have thought about OpenSSL, but they may have actually not thought about it because it's just so baked into there and like at the lower levels that they sort of forget that they're running on it, right, or using it, right, or reliant on it. And so that's why in a lot of the stuff that we do with the sort of census and like measuring this stuff, we try to look at the whole dependency stacks to understand like not just like what libraries are you calling specifically, but what are those built on and higher up the chain as well.
Yeah, that makes a lot of sense. I appreciate that.
Great.
Any final questions? Anyone? And I think that's the last one, Frank. Thank you again, Frank, for that very insightful conversation presentation about the value of open source. And to everyone in attendance today, thank you so much for attending for today's Tech Talk session. We hope you find the discussion very valuable and it is very thought-provocative session today. And if you have any other ideas and any topics you'd like to share in this Tech Talk format, please contact us directly at secretariat@globalplatform.org. We look forward to seeing you again in our next Tech Talk session. Until then, stay safe and stay connected. Once again, thank you, Frank. Thank you, everyone. Have a great day.
Thanks so
Bye.
much. Take care.
Thank you, Frank. Bye.
The question on slides, I can send them to Mac and he may be able to make them public for you all.
Yes, we will be posting this session. Thank you. Thank you, Frank. Bye-bye.